Given that a is equal to that expression over there, and x can be any number like 0, 1, 2, or 3, for which values of x will the expression a be rational? Okay, so rational is like a nice numbers. I like to call these the nice numbers. Some examples would be the number 3, minus 2, 1 over 5. That is still a nice number. It's a nice little fraction. 6 over 7, negative 1 over 3. You know, these are all considered to be nice numbers. What are ugly numbers? Well, ugly numbers would be things like square root 5. If you go type that on the calculator, I'll do that with you actually. You get like ugly numbers, 2.236, blah, 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 blah. So you're looking for really like really nice numbers. So for example, that number that I just said there, that would be irrational. That's irrational. But these nice ones, these are rational. And what's interesting about them, let's say for example, you go type that on your calculator. Try that, Solon. Yes, it has decimals, okay? But look at the decimals. They are going to repeat. Can you see it? It goes 0.8571428, and then it just starts again. 8571, 8571. So the decimals repeat. That is considered to be rational. But if I type in square root 5 on my calculator, then look at those decimals. They never repeat. 2.2360679. There's no repeating taking place, okay? And so anything that's like a fraction like this, that's going to have a repeating decimal, or the decimal would actually just stop. For example, 1 over 5, if you type in 1 over 5 in your calculator, it's actually just going to give you 0.2, and then the decimals don't carry on. All right, so the ugly numbers are called irrational, the nice numbers are called rational. Okay, so what we'll go do now is we will just go plug in these different values that they've asked us to use for x. So the first one is when x is 0. So let's go start with that. So then what we'll go do is we'll literally just go work it out. So we'll say 1 over the square root of 3 plus 0. Now if you had to go type that on your calculator, it's going to be an ugly number. It's going to be, and you can go check it out yourself, but it's going to be like 0.577350269. You know, the decimals aren't going to repeat. I don't see any repetition. What do I mean by repetition? Well, this would be repetition. 14136, 14136, 14136. That's what I mean by repetition. You see the parts that are repeating. I don't mean, oh, there's a 7 and there's another 7, so that's repeating. No, that's not what I mean. I mean that there's these parts that look exactly the same. Like they repeat like that. Okay, so that's an ugly number. So for which value of x will it be rational? Definitely not when x is 0. Let's go try when x is 1. So now you're going to say 1 over the square root of 3 plus 1, and that's going to be 1 over the square root of 4. This is a beautiful number. Check that out. 1 over 2. So yes, we will definitely want that one over there. Let's go try out when x is 2 now. So if x is 2, then you're going to get 1 over the square root of 3 plus 2, which is 1 over the square root of 5, which is going to be ugly. Yeah, you can go check it out, guys. It's really ugly. Okay, it's only 1 mark, so you don't need to show all of these parts. And then let's go try when x is 3. So when x is 3, it'll be 1 over the square root of 3 plus 3, which is 1 over the square root of 6. It's going to be ugly. Okay, so yeah, the only answer for this one is when x is 1. So we can just say when x is 1. Factorize the following fully. Okay, so step 1 of factorizing is always to try to take out a common factor. That's always the first step. Okay, so is there a common factor? Well, yes, you can take out a 2. Okay, so on the next step, we can show them that we're taking out a 2, and then you're left with x squared minus 16. Now, don't just stop. That's probably only going to get you 1 mark. It's a 2-mark question. So now what you do is you try to think of all the other types of factorizing, such as difference of squares, trinomials, it could be a cubic, which is something we learn now in grade 10, or it could be a grouping. You know, there's all these different factorizing techniques. Now, if you look carefully here, we've got 2 terms separated with a minus, and this one is a perfect square, x times x, and this one is a perfect square, 4 times 4. And so we can then break that up into 2 brackets because it's a difference of square, and so we can say x and x, 4 and 4, because x times x is x squared and 4 times 4 is 16, and then you can just put a negative in the one and a positive in the other. It doesn't matter if you put the negative and the positive in the opposite place, as long as you have one negative and one positive. Now, always check, can we go any further? Well, not really. And there we got 1 mark there, 1 mark there for 2 marks. Factorize the following expression fully. Okay, so what I would do in a situation like this is I would actually multiply this bracket out, and then I would restart. Okay, so we're going to put the a into the bracket, and then into that bracket, so that'll be negative 3ab. Now what I see is that there are 4 terms. Now that makes me think about grouping. Grouping, typically we do that when we have 4 terms. So I wouldn't group these two together because they don't have anything in common. That's a b, not a 6. I wouldn't group these two together. They don't have anything in common. But I know that, there's multiple ways you could do this. You could try grouping those two together because they have the a's and the 3's in common. Or you could even just group, for example, these two together and those two together. So what I would do now is I would go and rewrite it as 6a squared plus 2a. You see, I just slid that part to the front, and then I would just slide the minus b and the minus 3ab like that. Now, in this first part, I see that there is a common factor of 2, and there's a a. So then what would you be left with over here? Well, here you would be left with 3a plus 1. How did I just make sure? If you had to multiply these two together, that would give you 6a squared, so that's correct. And if you had to multiply these two together, that would give you 2a, so that's correct. Now here, this negative and this negative challenges a lot of learners, okay? So what you're going to do, guys, is let's take out a negative 1b as a common, or let's just, to make it easier, let's just take out a negative as a common factor right now. Then what would you have left over here? Well, you would have a b, and then here this would become a plus. Let me explain why. Because if you had to multiply this negative back inside there, what would that give you? Negative b, and that's what we had. What would this part give you? Negative 3ab, and that's what we had. You see? Okay, now going into the next step, we can go factorize this part further. So what can you take out as a common factor here? You could take out a b. So if you take out a b, then remember, there's still going to be a 1 left over here, and then a 3a over here. To make sure that everything's correct, if you had to multiply this in here, you would get negative b, which is what we had. And if you had to multiply this in here, you would get negative, because a negative and a positive is a negative, 3ab, and that's what we had. Excellent job. Look at these two brackets. They are actually the same. Now, some of you are like, no, they're not, Kevin. This one's 3a plus 1, and this one's 1 plus 3a. But remember, when you plus 3 plus 5, for example, is 8. 5 plus 3 is 8. So when you are plussing, order does not matter. When you are minusing, then the order does matter. For example, 5 minus 3 is 2. 2 minus 5 is, Kev. 3 minus 5 is negative 2. You see, order does matter when you are subtracting. But when you are adding, the order does not matter. So what I'll do is I'll quickly just change this to 3a plus 1. Now, we don't have a common factor. We have a common factor bracket. You can think of this as like a common bracket. You see that? So we can now take that out as a common bracket. Okay? So you could almost imagine that that part's disappeared now and that part's disappeared. And then what do we have left? Well, we have a 2a left over and a negative b. And you double check just to make sure you can't factorize any further. Nope, that's the answer. So there, 3 marks. Well done. Simplify. So look at that. It doesn't say factorize. It says simplify. So when you factorize, let's just quickly show you the difference. When you factorize, then you normally do something like this. You take out a common factor, and then you're left with that. So with factorizing, you end up with brackets in your final answer. When you simplify, you do the opposite. So when you simplify, you you multiply the brackets out, and so you end up with 2x plus 6. So your answer won't have brackets. But when you factorize, your answer does have brackets. So when they say simplify, we're going to get rid of the brackets by multiplying these two together. So how do we do this? Well, I take the first one over here, and then I'm going to multiply it with this one, then I'm going to multiply it with this one, then I'm going to multiply it with this one. Okay, so that's going to give me x3 plus x2 plus x. So I've now done this one with this one, and with this one, and with this one. So what I need to do next is I now need to take this one, and I'm going to multiply it with this, this, and this. So if I did with the first part, it's going to give me negative 1x squared. And then that next part will be negative 1x, and then negative 1. Okay, now what you do is you just put all the like terms together. So there's only 1x3, so I'm just going to write that. But if you look at this 1x squared minus this 1x squared, they would actually cancel each other out. So you're not going to... Some learners say, oh, does that mean I have an x squared left? No, you have 1x squared minus 1x squared, so you have 0. So you don't say 0x squares. 0x squares just means nothing. If you have 5 rands, you don't say I have 5 rands. You have nothing, bro. You have 0. So those cancel out. And then here we have positive 1x. Take away 1x. So once again, you have nothing. Well, there's nothing. And then here we have minus 1. Now, some learners might say, oh, but Kevin, can't we factorize this? This is a cubic, this is like we can use cubics. But remember, we're not factorizing, we're simplifying. So that is our final answer. For 5 marks, hello, simplify the following. Okay, so when you look at this, you can just remember the following steps. Make sure that all of the bottom parts, or let's first talk about the absolute basics. If I said 1 over 3 plus 1 over 5, what would you do? Well done if you said you would get a common denominator. Whenever you plus and minus fractions, you need to get a common denominator. So that's an important step. We need to get a lowest common denominator. But to get your denominators, you have to make sure that they are all factorized. Okay, so this one can be factorized, and this is a trinomial, so that can be factorized. So that'll be our first step. Let's just go factorize. Because if we don't, then you're going to tell me, oh, these two parts are completely different. But maybe they're not. If you factorize this, maybe it ends up looking very similar to that. Okay, so x plus 7. Now, if you factorize this, it's a trinomial. So let's factorize that over here together. So we look at the number 6. Now, we know that the number 6 can be written as 2 times 3 or 1 times 6. Now, which one should we choose? Should we choose the 1 and the 6, or should we choose the 2 and the 3? Well, how do we work this out? What we do is we look at this term here in the middle with the x, and we try to make minus 1. So you cannot make minus 1 using these two numbers. Like 6 minus 1 is 5. 1 minus 6 is negative 5. 1 plus 6 is 7. You're not going to be able to do it. So it's not that one. So we're going to use these two. How do you make minus 1? Well, you say 2 minus 3, because that gives you minus 1. So we're going to open up 2 brackets. Okay, and we're going to say x and x, and then we're going to say positive 2 for this one, because it's positive in the front, and then negative 3. And that is how you factorize that part. Okay, look at that. X minus 3, x minus 3. Ooh, something similar. Okay, now we're just going to leave this part because this is already factorized. Okay. Now here you can take out a common factor. A lot of learners forget about that. And look at that, x plus 2, hashtag just saying. So you guys must look out for that, okay? Now, to find your lowest common denominator, all you do is you just take all the different parts. So there's a x plus 2, we've got one of those. So that takes care of that and that. There's a x minus 3, that takes care of that and that, and then there's this random 2, which I'll just put in the front, and that takes care of that. Okay, so we've taken care of everything. So now what you do, okay, in the next step, you need to make all of these denominators exactly the same as that. So what that means is the following. It means that for this part here, if you look at this part, what is it missing? Well, it's missing the 2. So all we'll do is we will put the 2 there by multiplying, and then what you do to the bottom, you have to do to the top. You see how I put a bracket? Because if I just put a 2 there, then you would only be giving it to the x. What about the 7, bro? You got to be fair, so you got to put it in a bracket so that in the next step we will give it to both. Okay, excellent. Now we look at this part. Now look at this. What is it missing? Well, it's missing the 2 and it's missing a x plus 2. So what we'll then do is we'll give it the 2 and we'll give it the x plus 2. Okay, see how I used brackets? Because if I didn't, things look really awkward. Like what is that, bro? Come on. So you got to do that and you got to do that. Now what you do to the bottom, you must do to the top. So we're going to give it a 2. Don't put a bracket, otherwise you're going to think it says 23. And then we're also going to give it the x plus 2. Okay, now we look at this last part. What is it missing if you look at this part? Well, it's got the 2 and it's got the x plus 2, but it doesn't have the x minus 3. So we'll just give it the x minus 3. What you do to the bottom, you do to the top. And there we go. Now, what we are going to do is we're just going to put one long line. Okay, and you're going to put the bottom part like that, but we're not going to multiply the bottom part out. It's weird, right? I know that when you simplify, you're supposed to get rid of brackets, but not in the denominator. For some reason, we as mathematicians, they love to keep the denominator in the factorized form like that. But at the top, I just want you to go write everything out now. Please don't multiply anything together yet. It's going to cause some issues, trust me. So then what you do is you just say minus, and then you just say 2 times 3 times x plus 2, and you just say plus. There we go. Now at the top, we have some work to do. We have to go get rid of all the brackets at the top. Okay, so at the bottom, we just keep it as it is. Okay, I hope I have space. So you're going to multiply this 2 into this bracket. So that's going to become 2x plus 14. All right, my apologies. I had to go make a bit of space. So I erased the one step, and now I've got this. Okay, so that means we have 2x plus 2 and x minus 3. Okay, so as I said, we're going to multiply the 2 into that bracket, so you become 2x plus 14. Now here, just put these two together. So that'll just be negative 6, and then x plus 2. And then multiply this out, so that'll become 2x minus 6. Let's quickly do this step over here. So minus 6 times x is going to be negative 6x, and then minus 6 times positive 2 is going to be minus 12. So minus 6x minus 12. Minus 6, whoa, Kev. Minus 6x minus 12, and there we go. Okay, now at the top, you're just going to put all the like terms together. So you've got an x, another one, so that's 2 minus 6. Plus 2. So 2 minus 6 is minus 4. Minus 4 plus 2 is minus 2. Okay, let's actually just write the answer here. What did we say? 2, yeah, minus 2. Okay, and then we have 14 minus 12, which is 2. And then 2 minus 6 is minus 4. And then at the bottom here, you are going to do this. Okay, now you just need to do another little check at the top to make sure we can maybe factorize further. And in fact, we can. We can take out a negative 2, and then you'd be left with x plus 2. How did I do that? Well, check here. If you multiply these two together, what do you get? Negative 2x. And if you multiply these two together, you get negative 4, which is what we had. Now, the reason I did that is because if you now look at the bottom, we have things that can cancel out. So here we're going to have those cancel out, and the 2's can also cancel out. And so for our final answer, you're going to have minus 1 at the top, because there's nothing there except the little negative. And then at the bottom, you're going to be left with x minus 3. And that is our final answer. Simplify the following completely. Okay, so this is one of those questions where you see we've got these exponents over here which have x's in them, but then you've got all of these base numbers, 4, 9, and 6. Can you remember what to do? Well done if you remember. We need to drop each of those to their prime numbers. And this is when you can use the shift fact method on your calculator. So for example, type in 4 on your calculator, press equals, press the shift button, and then you're going to press the fact button. Now the fact button, it doesn't say fact on the button, it says fact just above the button. So look for that on your calculator. It might take you a few seconds, and you're going to press that and it's going to do this. So I want you to go do that for the 4, the 9, and the 6. Okay? So for the 4, it's going to be 2 to the 2, and then x plus 1. For the 9, it's going to be 3 to the 2, and then for the 6, it's actually just going to be 2 times 3. There we go. Now, what we are going to do next is we are going to go and multiply these exponents, because remember, what is this? What would this give you? Can you remember? If you say 7, that's wrong. 7 would be if it was like this. And it's okay if you said that. Sometimes we make these little mistakes. But what you would have rather done here is multiply. Okay, so we are going to go multiply this x plus 1 with this 2, and we're going to go multiply this x with this 2, and then we're going to go multiply this with the 1 that's over there and the 1 that's over there, because 2 to the 1 is still 2, and 3 to the 1 is still 3. Okay, so that's going to give us 2 to the power of, now multiply this 2 to both of those, so it will become 2x plus 2. Then for the 3, it will be just 2x. And then down here, we're going to get 2 to the power of 2x minus 1, and then 3 to the power of 2x minus 1. Excellent job. Now, what would this give you? A10 over A4. Well done if you say A6. So the idea is that when these two are the same, and you are the ones at the top and the ones at the bottom, then you're always going to take the top one minus the bottom one. Okay, but you're not going to cancel the A's out. You see, the A stays A. So listen up carefully. When you have a 2 over here and you have a 2 over here, you're not going to cancel them. You're not going to do that. Because just like over here, we didn't cancel out the A's. We just did the exponents, but we left the A as an A. Okay, it's a common mistake that learners want to cancel out these when they're numbers, and they want to cancel out those. Okay, so what you're going to do is you're going to leave it as a 2. And then you're going to take the top exponent minus the bottom exponent. But you see how I put it in brackets? Because there's more than one term. Okay? So you see what I did there? I took the top exponent minus the bottom, just like you did here. Or what was it? Was it a 4 here? You say the top one minus the bottom one, and so that gave you 6. Okay? And now we're going to do the same for the 3. So you're going to take the top exponent minus the bottom exponent. But the bottom exponent has more than one term. So put it in a bracket. Okay, I'm just running out of space. Okay. And now you're just going to go simplify. So you're going to say 2 to the power of 2x plus 2. Then this minus is going to go into both of those. So it'll become minus 2x plus 1. Because a minus and a minus... let's write that a bit better. Becomes a plus. Ooh, guys, my hands are so cold right now. It's winter. Well, obviously, at the time I'm recording this, it's winter. It might not be winter when you watch this. But my hands are so cold right now. I should probably wear gloves. Oh, no, but then it's difficult to write with gloves. Okay, let's move on. So with the 3, with the 3, we're going to say 2x. Now, this minus is going to multiply in, so it's going to become minus 2x plus 1. And so that's going to end up becoming 2 to the power of, now this 2x and this minus 2x, they would cancel out. And then this 2 plus 1 would become a 3. So 2 to the power of 3. And then here, we're going to get 2x minus 2x, which cancels out. And then you're left with a 1. And so what is 2 to the power of 3? Oh, by the way, don't make this a 6. Why? But Kevin, 2 times 3 is 6, bro. Yeah, but this isn't 2 times 3. This is a 2 to the 3 and a 3 to the 1. So it's a little bit different. So 2 to the 3 is 8. 3 to the 1 is 3. So if you say 8 times 3, that is 24. So with this question, sorry about the gray at the background, it's just the exam paper that I got. It says, if x is an even integer, let's talk about that quickly. Even, okay, so we know the even numbers, right? 2, 4, 6, 8, 10, 12, blah, 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 blah. That also includes negative 2, negative 2, negative 4, negative 6, negative 8. Integer just means it's a number like a whole number, not a whole number, but like it doesn't have any decimals. So it's like any negative number, any positive number, but with no decimals. So not like 6,3. That's not an integer. Integers, numbers like -2, -4, -6, -8, 12, 18, and they must be even numbers, okay? So like 2, 4, 6, 8, 10, 12, or negative, okay? They tell us if x is an even, and they tell us that x is larger than 1. Oh, okay, so x is larger than 1, so we can't have any of the negative numbers. So we're only going to have numbers like 2, 4, 6, 8, 10, 12. Okay, arrange the following in ascending, so from smallest to largest. Okay, I think let's try something. Let's say that x is 2, because they said x is an even integer and x must be bigger than 1. So let's just say x is 2, and then I'm just going to go plug that into each of these and see what we get. So if you have negative 2 to the power of 2, you end up with negative 4. If you have 2 to the power of 2, you end up with 4. If you have 2 to the negative 2, you end up with, you can type it on your calculator, it's a quarter. If you say 2 to the power of 2 to the 0, that becomes 2 to the 1, because 2 to the 0 is 1, and that just gives us 2. And then this one is 2 to the power of 2 squared, which is 2 to the power of 4. That's a 4, and so that's 16. Okay, so we can see the smallest, from smallest to largest. So the smallest one is this one over here, so that's negative 2 to the x. Then the next one is this one over here, so that's 2 to the negative x. And then the next one is this one over here, which is 2 to the x0. And then the next smallest one is this one over here, which is just 2 to the x. And then the next one is this one, which was 2 to the x squared. 2 to the x squared.
Hey.